Hi guys, we already prepared pretty much everything so that we easily can improve our calculator so that it also supports variables. And this actually will be your next exercise. In this video I want to walk you through some preparations for this exercise, not just about how to change the grammar for this calculator and how to implement then the new calculator, but also how to reorganize source files and header files so that later on we can easily reuse components for our compiler project. The calculator simply needs from the parser this parse input sequence function. All other functions are just relevant for the internal implementation of the parser. And when I'm using simply one function of the parser, why should I call it parse input sequence? Because this is some detail about the grammar that is not relevant for using this parser. So the first change that I want to make is renaming this function into simply parse. And then I also want to have an extra source file for the parser with its own header file. So I actually want to have this change. Now let's do this together so that we have the same base for continuing with the improvement of the calculator for adding variables. So let me first rename this parse function. I simply remove this input sequence from every occurrence of parse input sequence. And then I copy this complete source file into a new source file parser.c, because most of it will be the parser. And in the test program I now simply remove everything from here to here. And then I already include the header file for Lexer and the new parser. The parser header file, of course, currently does not yet exist. And maybe also this comment here. And then here I remove the function main. And then I remove this, I save it in a register, and I also want to sort the header files here. And then I include the header file for the parser itself. And then I can write the header file. So the usual pattern for the include guards. And then I can paste the declaration from my Vim register into here. Okay, and now everything still should compile and work. I want to make another minor improvement to our calculator before we continue, because it's becoming annoying that we write everything to standard out. Sometimes I just want to see the value of an expression, and sometimes I want to see in addition this LaTeX code for an expression tree. And actually it would be nice to have it in a way that I see on standard out always the value of an expression tree, and this LaTeX code gets written into a file. And this is exactly what I show you how to implement this. I will first add a function set parser log, and if you use this function, actually only then some LaTeX code gets written to somewhere. You can specify in this function a file pointer, and to this file pointer all this LaTeX code will be written. So for example, you can specify standard error. Then the LaTeX code gets written to standard error, and you can redirect only standard error to a file, and on standard out you still would see the value of an expression. Now this change of course has consequences. It means that you have to change all these print functions in expressions, and all these printfs that are relevant for printing in the expression tree have to be changed into a fprintf with a specified file pointer. But once this is accomplished, we afterwards could use a program argument to specify a file name. Then we open this file and then pass the file pointer for this opened file to this set parser log function. And I think this will be a nice enhancement for the calculator, and it's actually not that hard. So let's begin with the declaration for a function where we can specify for the parser log a file pointer. And then I also have to include standard IO. And then let me copy this declaration. And then I begin with the implementation in parser.c. So everything for this log support comes here. I will have one global variable for this file pointer. Actually, this should be then static. And then this function for setting this eventually to something different from the 0 pointer. And then, of course, I should rename this parameter to avoid name conflicts. So this simply assigns this parameter to out. And then in parse expression statements, I now can print the evaluated expression as before. And only if this file pointer is different from the 0 pointer, then I want to print this parse expression tree into this file. And then I also have to update the header file for expressions. I also have to include here standard IO because this declaration will now have this file pointer. This new declaration for printing expression trees. And before I continue, I now will first check whether I can generate an object file for the parser. And I also should be able to do this for the calculator now. Okay. For expression, I of course cannot do that. This will now be a major change. And I will begin with the function print indent. This now gets an additional parameter, and this printf will be changed into fprintf, and out will be the first parameter. And then I have to change all the function calls for print indent. I simply search for that, and wherever this occurs, I add this additional parameter dot comma out. Okay, that's it for print indent, and the next print function is print expression node. And here I also just add an additional parameter's last parameter, and then I again search for every call of this function. Okay, and here I also have to change all the printfs into fprintf out, and I will record this so that I can redo this change for all the other printfs. I just have to apply this recording. Yeah, like that. Okay. And now I simply search for the next printf and replace. But of course I have to be careful. I should not change the fprintfs for this error messages. So that's why I'm not doing a global search and replace. Okay, this here is okay. That's the output for LaTeX. This all needs to be changed. Okay, and that's probably it. Okay, the next print function. Let me search again for print at the beginning of a line. Okay, that's the next definition. And here I also add a parameter in the end and search for this course of print expression tree underscore. And not exactly rocket science, but we want to avoid here lots of error messages, and this simple approach usually works, doing it function by function. Okay, and now I can also change the test program so that I actually make use of this new feature. I want to set here set parser log to standard error, and then I already can test this. Okay, first I want to check whether it's still working at all. It should now always print the value of an expression and the expression tree in LaTeX. Yeah, and now I also want to redirect standard error to some file. Same expression, and now the file should have the content that you saw before. Now let's see what the rest of the project is saying to these changes. Here we still have some other calls to print expression tree, but in this one test program. So let's change this so that we specify here standard error as second parameter manually. Okay, something else? No, rest compiles now. Now let me show you what still bothers me. If I have more than one expression statement, I cannot generate from this LaTeX code some PDF, because I will have the header and the footer of this LaTeX document twice. You see here, I have hero document class and here, and this of course is annoying. So what I will do is I will change this print expression tree function, so it will only print the content of the document. And let me first copy here this complete block, because I need the header and the footer later. So I will copy this into a Vim register, register X, and then I remove here simply everything, including this begin document and this end document. And then in the calculator, I will implement two functions, a print header and a print footer function. And print header will print from this lines below, a few lines, everything including this begin document. And this can be removed now. And print footer will only print end document. And now I first call print header after setting the parser log, and after parsing I print the footer. Okay, now let's see. First expression statement and maybe some more complicated second one. And now the LaTeX code looks better. So let's translate this into a PDF. And let's have a look at that. Yeah, nice. Okay, let's do this again in one command line. Some shell magic. So now I can type in some expression statements, and after I type in Control D, automatically I will see the PDF. Maybe I also should use some power expression. Yeah, okay, so that's it for now. And yeah, nice. Okay. Now the next step, of course, would be to use a program argument to specify into what file this LaTeX code should be written. And then we have to check whether we have too many arguments. Then we should print a usage message and exit with exit code 1. The usage message will get the name of the program, and if we have exactly 2 arguments, then we set some file pointer, and otherwise this should be the null pointer. So I also have to define this file pointer, and I also have to write this usage function. Of course, I should print this to standard error. And actually, the message should be usage colon, then the name of the program, followed by the optional argument to the program. And after that, I have to exit. So I also have to include standard lib. Okay. And then only if this file pointer is set, we will call set parser log and print header with this file pointer, of course. And otherwise we just print the value of the expressions. Okay, typo. Okay, with no arguments and with 1 argument. Of course, this will not really write something to a file, but to standard error. Now we actually also could change that we actually open a file with the file name specified as argument, and of course we want to write to this file. Okay, let's test it with some simple expressions. And now we should see in foo.tech exactly this content. Now let's also check if we specify too many parameters that we get actually the usage message. Yeah. Now the last thing to do is some error handling. If we cannot open the file, we should print an error message and exit with an exit code unequal to 0. And of course some nice error message. Where we see the name of the file where we had this problem. And we also should close the file before we terminate the program. Okay. And now of course we should test this. We can try to write something to the file dot, which is a directory and certainly cannot be used for writing something to it. Okay, seems to work. So that's it. Rearranging the existing code was actually the hardest part. Now we finally can begin with making the improvement to our calculator so that it's also supporting variables and assignment expressions. Of course, we will begin with making changes to our grammar. Expression statements are now assignment expressions followed by a semicolon. And for assignment expressions, I would like to allow, like in C, multiple assignments. That means I basically can take the grammar from C and use it for our calculator. So an assignment expression now can be just an expression, but optionally it can be followed by an assignment operator and an assignment expression. So that means, like in C, the assignment operator is right associative. And then the final change will be that a factor now also can be an identifier. But that's it for the grammar. The EBNF grammar is already in a form where you simply can apply this known patterns for translating every production rule into an implementation of a parse function. So this will be kind of simple. However, you also have to do some semantic checks in the parser, because our grammar allows on the left-hand side of the assignment operator an arbitrary expression. Here, however, it's required that we actually do have an L value. We want to assign something to this expression. Of course, we already prepared everything to make this simple to check. We have in this data structure for expression nodes this method for checking whether an expression is actually an L value or not. So this also actually is not a big deal. Then you also have to make sure that for every identifier that you find, there is a corresponding symbol in the symbol table. If this is not the case, you have to add a new symbol to the symbol table for this identifier with a default value of 0. So this also shouldn't be that hard. So I think you can have fun with the next exercise, implementing this calculator with variables and assignment expressions.